Hey guys, it's me, Miss B. Today we're continuing on with rational functions in our graph. Last time we talked about vertical asymptotes and we talked about slant asymptotes. So today we're going to talk about horizontal asymptotes, and then we're going to work on some graphing. So there are three types of horizontal asymptotes. The first is going to be when the degree of the numerator is lower than the denominator. Then there's going to be an asymptote at y equals 0. So an example of that is y equals x to the first over 3x squared. The numerator is less than the denominator, so there is an asymptote at y equals 0. The second type is if the degree of the numerator is equal to the denominator, then there's going to be an asymptote at, it's going to end up being the coefficient of the numerator over the coefficient of the denominator, and that's a y equals equation. So for this one, here is I have matching degrees. So the coefficient of the first is 3, coefficient of the denominator is 7. So y equals 3 over 7 is the asymptote. Finally, this one here is if the degree of the numerator is greater than the denominator, there's not actually going to be a horizontal asymptote. So really there are only two types, but those are the three scenarios. So for this one, 5 is greater than 1. So there is no horizontal asymptote anywhere. So we're going to find the horizontal and vertical asymptotes of these functions down here. So if you need to review your old notes, you can. Let's find vertical asymptotes first. So our vertical asymptote for the first one, we have to set our denominator equal to 0 and solve. So we get x equals -6 as our vertical asymptote. For our horizontal asymptote, we have to test our thing. So we have to, this is 3x to the first, and this is x to the first. 3 is greater than 1. Oh, I'm sorry. 1 is equal to 1. So then it's going to be a ratio of the two. So it's y equals 3 over 1, or just y equals 3. All right, next up, let's go ahead and factor our numerator just so we can see if anything cancels. We get x times x plus 3 over 2x minus 5. Nothing cancels, so we'll just kind of ignore what we just wrote. For a vertical asymptote, we are going to write 2x minus 5 equal to 0 and solve, so we get x equals 5 over 2. For a horizontal asymptote, we have to see our ratio. So 2 is greater than 1. So 2 is greater than 1. So there is no horizontal asymptote for that one. All right, and then lastly here, I have 3x over 2x squared plus 7x plus 5. For my vertical asymptote, I need to set 2x squared plus 7x plus 5 equal to 0 and solve. I do have to factor. Go ahead and factor on your own. All right, what you should have put is you should have had 2x squared plus 5x plus 2x plus 5, because 5 and 2 both multiply to be 10 and add to be 7, because our PSN is 10, 7. And then we split the middle. And so we want to factor each of those parts. So we've got 2 times, we pull out our GCF, so we have x. So we have 2x plus 5. This one we just factor out a 1. There's nothing in common, so we get 2x plus 5. So then 2x plus 5 times x plus 1 is our factored form, and we set both of those parts equal to 0. And solve. So we have x equals -5/2 and x equals -1 for those vertical asymptotes. You do need to write them as equations. All right, and then for our horizontal asymptote, my degree of my denominator is greater than my numerator. And so my equation is y equals 0. I don't even have to do any math. Okay, so let's go ahead and graph one of these together, and then we'll do the other one in class together. I'm actually going to mark that now. So this one we will do in class. Okay, so first let's talk about our x-intercepts. Remember that if we're finding our x-intercepts, we're setting y equal to 0, and if we're finding our y-intercepts, we're setting x equal to 0. So throwback to Algebra 2. So let's just do the math before we graph. So for our x-intercepts, we're going to have 0 equals 2x, let me change my pen size. 0 equals 2x squared minus 6 over x plus 2. We're solving for x. Multiply both sides by x plus 2. Maybe do it in a different color. So these are going to cancel. We're left with 0 on the other side. So get 0 equals 2x squared minus 6. Add 6 to both sides and divide by 2. You get 3 equals x squared. We have to take the square root of both sides. When we do that, we have to put plus or minus. So x is equal to plus or minus the square root of 3, which is about 1.7. And we want to just round it for our graph. So let's go ahead and save that for later. All right, our y-intercepts, we're going to plug in 0 for x. So we have y equals 2 times 0 squared minus 6 over 0 plus 2. So we get 0 minus 6 over 0 plus 2, which is -3. So our y is -3. All right, for a vertical asymptote, go ahead and find that on your own. All right, for the vertical asymptotes, you want to set your denominator, x plus 2 equal to 0, and solve. Go ahead and find your horizontal asymptotes. So you should have noticed that 2x squared over x, I'll just write the whole thing. Just looking at those two front parts, 2 is greater than 1, so there is no horizontal asymptote. For the slant asymptote, you'll notice that we have a degree of 1 more in the numerator than the denominator, so we're going to use synthetic division. So I have x plus 2 equals 0 and solve. Then I'm going to set it up with my number. So I have 2, 0, and negative 6. Come down here and do my synthetic division. So we're going to drop down that 2, multiply, add, multiply, add. We're going to forget our remainder, but our line will be 2x minus 4 for that slant asymptote. All right, so then we're going to graph all these things. Our x-intercepts and y-intercepts, these are points. So this is actually going to be the point. Our x is going to be x, so plus or minus 1.70. And then for y, it would be 0, negative 3. Just a reminder there. So let's go ahead and graph those. So 1.70 is about right there, and negative 1.70 is about right there. And then we're going to graph the point 0, negative 3. So those are our intercepts. I'm going to do our asymptotes in blue. So I have a vertical asymptote at x equals negative 2, so it's just a straight line up and down. So that's our vertical asymptote, x equals negative 2. I don't have a horizontal asymptote, but I do have a slant asymptote at 2x minus 4. So here's minus 4, and then 2 is my slope. So this ends up being, let's go down 2 over 2, 2, 2. So this looks like this here. Okay, we do want to put arrows on those because they do go on forever. So this is our slant asymptote of y equals 2x minus 4. You can see that it's minus 4, and then its slope is up 2 over 1. All right, and then to graph our line, it's just going to go through these points here. So we've got this. It's going to really come close to those vertical asymptotes, but not go through them. If you don't draw it perfect, that's okay. And then down here, we'll have another one that's kind of a reflection of the other, and you can just kind of eyeball that one for now. Okay, and then we'll do the second one